Hi, once again, Mr. Wakefield back here with we're moving along here with the next section of Chapter 4, Section 4.3. And what we're going to be doing in this section now is we're going to be looking at something that allows us to measure how steep a line is. For example, if you have a line that's really steep like this, it's obviously got different steepness compared to a really almost flat line like that is. And then what happens if it goes the other way? What happens if it goes this way? It's really steep, but it's going down as you move from the left of the page to the right of the page. Okay, how does that affect it as well? Because these two lines look like they're kind of the same as far as how steep they are, right? So does that mean I use the same measurement? No, I don't, okay? Because then it'll make it look like the lines are the same line. So we've got to be able to tell the difference between these two as well. That's where the concept of slope comes into play. All right, that measures the steepness using a number. Usually it'll be a fraction, but it is a number nonetheless that measures how steep the line is. So there's four different types of slopes that we're going to look at, all depending on what kind of line you have. Those four examples are right here. You can see that I've written some additional information in there. I'll give you a chance to write that in there as well. There's four different types of slopes here: positive, negative, zero. Okay, you don't have to write out the word zero. You can just say the number zero there as well. And then also undefined. We've seen undefined before. For example, when we had the square root of a negative number and there was no answer for that, we didn't word it with the word undefined, but it does mean the same thing. There is no answer. We call it an undefined answer. So this actually has no slope here. It's an undefined slope. We'll talk about why that's true coming up. But let's start out over here first. Why is this a positive slope? Well, first of all, let's look at these two together here. Positive is when the line is diagonal. It's not horizontal or vertical. That's what I mean by diagonal, okay? Anything that's not horizontal, straight across, or vertical where it's straight up and down, that would be a diagonal line, right? So if it's a diagonal line where it moves up as you go from the left of the graph to the right of the graph, okay, as you're going from over here to over here, the line is going up, okay, then that means that it's going to be positive. When it's going down, as you move from the left part of the graph to the right part of the graph, the actual graph is going down. See how my pencil is moving from the left of the graph to the right of the graph, and it's moving down at the same time. That's when it's negative. So positive if it's going up, negative if it's going down, assuming that your pencil's moving from left to right at the same time. Okay, so how do we measure it exactly? We're not just going to call it positive. There's actually going to be a number. And like I said, it's usually going to be a fraction. How do we determine what that fraction is? Okay, here's what you do. You start out taking any 2 points on the line, just as long as they're two different points. Okay, it doesn't matter what 2 points they are. And you always start out at the point on the left. Okay, this point obviously is further to the left of the graph than this one is. Okay, so you start out at the point that's further to the left, all right, with the smaller x, in other words, all right. What you do is, if it's positive, you're going to rise and then run to the right. Let me show you what I mean by that. So you take that point that's on the left and you're going to rise, and don't make a line here, okay? Make this like a dotted line. You don't even need to do the dotted line. I'm just saying that if it helps you visualize it better, you can make a dotted line right here. But I'm going to rise all the way up until I'm straight across from the other point. All the way until you get there, okay? So I'm going to rise until I get to there. You can see I'm now straight across from that. How many marks did I have to go up? Okay, well, you can see that this point right here, that point actually was originally at y equal to -2. So in order to get up to here, which has y equal to 4 right here, you can see that this lines up with y equal to 4. How far up do you have to go? 1, 2, 3, 4, 5, 6. Do not jump over the x-axis, by the way. You got to count that. So let me do it one more time. starting at -2, and we're going to go 1, 2, 3, 4, 5, 6. So that means that we rose 6. So the top of the fraction right here is going to be a 6 because that's how much you rose or how much you rise. Okay. See how I made a fraction right here. So in this particular case, the slope is going to be 6 on top of the fraction. Okay. What is the bottom? The bottom is after you rise, you figure out how far do I have to run to the right. So going from here to here, running to the right. Again, I'll make a dotted line here just so you can visualize it better, but you still got to count it. Okay. This right here is -1, -2, -3, -4, -5, -6. So this is where it starts. This spot where it turns here and starts running to the right, that's at x equal to -6. So you have to count from x equal to -6 all the way over to this point here, which is where x is equal to 1. So if I count that out, what is that? 1, 2, 3, 4, 5, 6, 7. Again, don't jump over the axis. You got to count that. So we go it's 7 spots, 7 marks that you got to count out in order to get from this corner right here where we turned to get over to where the point is. Okay, so we had to rise 6 and then run 7 to get to that other point. All right. And so that's how slope works. You pick any 2 points that are on a line. These are the 2 points I picked. All right. And if it's positive, and if it's negative, we got to do something different. But if it's positive, you figure out how far you got to rise and how far you got to run to the right in order to get to that next point. So don't rise too far. Just rise until you get to on the same level as that other point, and then just run to that point and figure out how many marks you had to count in order to get there. So the slope in this particular instance is going to be 6/7, okay? But the slope will always be positive if you have a line that goes up as you move from the left of the graph over to the right of the graph. All right, that's how it works with positive slopes. Now, if you have a line that goes down, like I said, as you move from left to right, then it's going to be negative. So we'll make sure that the fraction here ends up being negative. Here's how it works, though. You don't rise. If I rise and run to the right, I'm never going to get to this point, am I? Okay? That's never going to happen, is it? All right? Because you're supposed to start out with the point that's on the left. If I start on the point on the left and I rise and run, I'm going to be way up here, right? So with negative slopes, you don't rise and run. You drop and run. You still run to the right, but you just drop, okay, before that instead of rising like you did up here. And it's all because the graph goes down as you move from left to right. So I'm just going to, again, make a dotted line here just to make it easier to see. Again, that's completely optional. You don't have to do that. You don't have to do the dotted line. But looking at that dotted line going down, how far did we drop? Let's count it here. This originally was, excuse me, this is originally at y equal to 5 right here. You don't have to write down the 5, but I'm just telling you. Okay, that's a y equal to 5. And so to get all the way down here, how far do we got to count? 1, 2, 3, 4, 5, 6, 7, 8. So you have to drop down a distance of 8 right here. A distance of 8 to get from the point that was on the left all the way down to where you have to turn. So that's how far you go before you got to turn. Now, when I turn and go and I run to the right like the directions tell me to here, after I drop, I got to run to the right. How far do I go there? Well, from this corner right here, I got to go. You can see that this is at x equal to -3. This is x equal to -3, so I got to count it out. 1, 2, 3, 4, 5, 6, and then I'm lined up with the second point after I count over 6 spots. So that means that the slope is what? The slope is not 8/6, but -8. You got to make it negative because why? Because we know that when the line goes down as you move from left to right, we've got to make it negative. So even though I didn't mention any negatives in there, okay, you've got to make it negative, All right. We got to make it negative because that's how lines always are when they go down like that. So the slope is negative 8/6. Yes, you could reduce that fraction. It is what? If you reduce that, it is negative 4/3. Okay. All right. So if it's positive, in other words, if the graph goes up, then you rise and run to the right to go from the leftmost point over to the rightmost point. Okay. And that's how you figure out the slope. Again, this was 7 right here. I forgot to mark that there. So that's why we got 6/7. And when the graph goes down, that automatically means it's negative, which is really important to remember because that reminds us to put a negative in our answer when we do the slope. And then we drop and run to the right. Dropping and running to the right gives me 8 and 6. And so the answer there is negative 8/6, which reduces down to negative 4/3. Okay. Now, as we go on into the last two types of slope here, what's different about these last two graphs here? They're horizontal and vertical. As we saw in the first couple of sections of 4.1 and 4.2, horizontal and vertical create a whole different situation when we graph, while it's no exception when we look for the slope as well. If you have a normal line that's neither horizontal nor vertical, you're just going to do either rise and run or drop and run. Okay, but when it's horizontal or vertical, there's something wrong. I'm sorry, I shouldn't say there is something wrong. I would rather say there's something that would be wrong if you tried to do it this way, because it's different. Okay, here's the problem with a horizontal slope or horizontal line rather. It doesn't rise or drop at all, right? When something goes straight across like that, it's not rising at all and it's not dropping at all. So that means that the numerator of the fraction, whether you look at it from a rising perspective or a dropping perspective, either way, the answer on top should be 0 because it's not rising or dropping. And so, therefore, the slope on the top of the fraction should be a 0. Now, as you can see here, if I figure out how far it runs, see how it doesn't rise or drop at all, so the top is 0, but it does run from this point to this point. It runs a distance of 1, 2, 3, 4, right, to get from that point to that point. So it runs to the right 4, so the slope is 0 over 4. But what is 0 over 4 equal to? Well, anytime you have 0 divided by any non-zero number, doesn't matter if it's 4, 3, 7, 10, whatever it may be, okay? Anytime you have 0 over non-zero, in case you don't remember that from your previous studies in math, that is always equal to 0. Always. 0 divided by anything that's not 0 on the bottom is automatically equal to 0. And so that's the reason why we say that this slope right here is 0. 0 over 4 is equal to 0. Okay? And so that's different than this, though, and I'll show you why here in just a moment. In fact, I'll do it right now. You can see that with a vertical line, instead of not having any rising or dropping like the horizontal line didn't, this actually doesn't have any running. Okay? In other words, it doesn't move to the right at all. Okay, when something goes straight up and down, it doesn't move to the right at all, does it? All the other lines we looked at, they move to the right, which is why we got this denominator here running to the right. This doesn't move to the right at all. It just rises only as you go from this point to this point. Or if you look at it from the standpoint of this point first, going down to here, then it's dropping. But the point is that it doesn't matter which way you look at it, as you're going to find out here in a second. Either way, the answer is going to be the same. So let's just say that we looked at it. It really doesn't matter when it's a horizontal or vertical line. It doesn't matter which point you look at first. If it's a positive or negative slope, you always got to start out on the left. But if it's horizontal or vertical, it doesn't matter which one you start with. So if I start out with the bottom one and I rise, how far do I go up? I go up 1, 2, 3, 4, 5, right? To get up to that other point. But there's no run at all. And we know that the running is always in the denominator. So it makes logical sense then that the denominator would be 0 then, since there's no running at all. Is this also equal to 0, 5 divided by 0? No, it's not. Okay, let's write this down. Non-zero divided by 0 is equal to undefined. There is no answer for that. I'll explain why here in just a moment. Let me write this down first. There we go. Okay, so if the numerator is 0 and the denominator is not, then the answer is just the number 0. But if it's the other way around, when the top number is not 0 and the bottom number is 0, that's got no answer, so we call it undefined. Let me show you why that's true. Okay, you don't have to write this down what I'm about to ready to do here on the scratch paper. I just want you to understand why these two things are true right here. This and this. Okay, remember back when you first learned about division? And they taught you that 6 divided by 3 was equal to 2. Why is 6 divided by 3 equal to 2? Well, there's a lot of reasons, but one of the reasons is because if you take the denominator and you multiply by the answer, 3 times 2, isn't that equal to the numerator? That's why 6 divided by 3 is 2. It's because the denominator times 2 is equal to the numerator. That's what makes it so that 2 is definitely the right answer. Okay, let's do that again now. What about 0 divided by 4? How do I know that that's equal to 0? Let's do the same thing again. We take the denominator and we say 4 times what, you guys? 4 times what is equal to 0? Whatever makes that work is the answer. 4 times what is 0? Let's write in the answer right here. We know that 4 times 0 is 0 because anytime you multiply something by 0, you get 0 as an answer, right? So I know that when the numerator is 0 and the bottom's not, we're going to get this situation where you got 4 times 0 equal to 0. That's why the answer is 0 when the 0 is on top. But, and here's the tricky thing. When the 0 is on the bottom, let's do the same thing again. Denominator times what is equal to the numerator? 0 times what, you guys, is equal to 5? Well, that's impossible. There is no answer for that. How come? It's because 0 times anything is 0, not 5. It can never be equal to 5 because 0 times anything is always equal to 0 all the time. And so that's the reason why, you guys, that when the 0 is on top, the answer is 0. When the 0 is on the bottom, it's undefined. And that's the reason why horizontal lines always have a 0 slope. It's because they have no rise or drop, and the rise and drop is in the what? It's in the numerator. Whereas for vertical slopes, there's no run. And since the run is in the denominator, that means that the denominator is 0 for vertical, and thus that then leads to this denominator being 0 means that it must be an undefined slope. Okay, so we have 4 different slopes here total. Positive when it goes up as you move from left to right. Negative when it goes down as you move from left to right, but both of these are still diagonal though. Horizontal when it just goes straight across, and it's a 0 slope in that case. And a vertical line when it goes straight up and down, that's always an undefined slope all the time. So let's try that out here on some more sample problems here. The first point here, and I'm going to use these actual numbers here in just a moment. The first point is what, and the second point is what? The first point is 0, 2. X is equal to 0 and y is equal to 2 right there. Okay. The second point is what? Let's see here. It looks like it's x equal to 4 right here, and it's y equal to 5 right here. So I'm going to write that down, 4, 5. There's 2 different ways to figure out what the slope is equal to when you have a couple of points on a line. Okay. The first way to figure it out is by looking at the rise and run. And I say rise and run this time because it is a positive slope, so it's definitely going to be rising and running here. Okay, just like I just taught you here, Okay, if you take the point that's on the left and you rise and run in order to get to the point on the right, how far did you have to go for the rising and how far did you have to go for the running? Well, it looks right here like I have to go a distance of 3 to get up to the point where you got to turn around. I kind of run it off to the side here so it doesn't collide with the y-axis. But from this point, which is at y equal to 2, up to this point here, you count what? 1, 2, 3. Let me zoom in a little bit there for you. All right. 1, 2, 3. And so the rising part of the slope is 3. And then how far over do we have to go to get from this point, which is where it lands after you rise, to get from this point to this point? You got to go over 1, 2, 3, 4 until it lines up with that point. So that means that we ran to the right a distance of 4. So rise 3, I'm following this fraction here, rise 3 and then run to the right 4. And so therefore the slope is positive 3/4, not negative 3/4, but positive 3/4, because it's always got to be positive when you go up as you move from left to right. Let's do that again here on the next one here, and then I'll show you the alternate way of computing these slopes, all right, because sometimes it's easier to do it the other way. Okay. You can see here that the first point in the next problem is the one that's on the left, that is. Always start at the left when you're doing this thing where you rise and run or drop and run. Okay. That is -1, 2. -1 for the x, 2 for the y. All right. And then the second point, what is that? That looks like x equal to 1, 2, 3, x equal to 3, and y equal to -1. So 3, -1. 3, -1. All right, so since the graph drops, goes down as you move from left to right, we're going to use the drop and run method this time. Just like I did up here with the 8 and the 6, same thing. Okay, so that's going to be what here? That's going to be, I'm going to drop down, what is that? 1, 2, 3, and then I'm going to run how far over? Okay, so I'm dropping 3, and then I'm going to run how far? I started out at y equal to negative, or pardon me, x equal to -1 here, so I got to go 1, 2, 3, 4 spots, and so that is 4 that you run to the right. So the slope there is not 3/4 though, it is -3/4, because you got to force the slope to be negative when it goes down as you move from left to right, just like in this example up here. Okay. And so the slope is -3/4 right there. Over here it was +3/4. All right. Now, let's say, for example, and you see these examples down here at the bottom. Let's say, for example, instead of putting those 2 points on a graph and then doing the rising and running, let's say that you were just given the 2 points, but they weren't on a graph. You have the option to graph these and then do the rising and running if you want to, just like I did here. You could put these 2 points on a graph and then do the same thing we did here. Or you can use a formula that we have. It's at the top of the page. Okay, it will give you the same answer, I promise you. Okay, but let me explain what this formula says. There's a lot of little symbols in here, isn't there? It says that anytime you're given 2 points, whether they're on a graph or if they're just written down separately like right here without graphing them, either way, okay, if you know the x's and y's of each point, which we do in this right here where it says 0, 2, and 4, 5, we know the x's and y's right there. So the formula says, in fact, I'll bring it down here off to the side so we can look at it right next to the problem. What this says right here, I'm just rewriting what's at the top of the page here. Same thing. This is saying to take the second y value minus the first y value. That's on top. And then this is saying down here the second x value minus the first x value. Make sure that the y's are always on top. The y's are always on top. Okay? But if I did that, what would I get here? The second y is 5. In other words, the y from the second point. The second y minus the first y is 5 minus 2. And then it says take the second x minus the first x. So that is 4 minus 0. Make sure that you do it in the correct order, because if you reverse it around, it's going to mess up the answer. In other words, 2 minus 5, you guys, that's not the same answer as 5 minus 2. 2 minus 5 is negative 3. 5 minus 2 is positive 3. So make sure that you do second minus first for the y's, second x minus first x on the bottom, in that order. What do we get? Well, we do order of operations here since this is a fraction with no variables in it, and we just got a fraction to figure out here with no variables. And so that means to figure out what the top and bottom are equal to if you've just got a single fraction. And then reduce it after that if you can, but it's already in lowest terms. And as you can see there, we got the same answer, just two different methods for doing it. So if you just want to do the x's and y's plugged into this formula, you'll get the slope. If you want to graph the points, if they're not graphed already, and then do either rise and run or drop and run, depending on the type of graph you have, you're welcome to do that also. Let's try that again over here. Okay, if I do that on this one, I get second y minus first y, negative 1 minus 2. Okay, and then this one, here's where you got to be careful. A lot of students miss this. Remember, there is already a minus sign built in to the formula. Okay, the minuses are already there. So if I say 3 minus negative 1, that's a double negative. In other words, the minus is already there. So if I plug in a negative number behind the minus right here in this formula, that's a double negative, and it makes it 3 plus 1. Because the minus is already there, and so if you have a negative plugged in behind that, and the first x right here is negative, it's negative 1, so we got 3 minus negative 1. When you have minus and then a negative behind that in this formula, it's telling you that it's a double negative, and you got to change it to plus. Just like we always do when we have a number minus a negative number, it becomes plus, doesn't it? Don't forget that. Don't let it become minus 1. It's a double negative. It's got to become plus. And we end up with, as we saw here, negative 3/4. You might be wondering, does it matter if the negative is on the outside or if it's on the top there? As we have talked about briefly in the past, but let me make sure it's clear here. Okay, when you have a negative on the outside of a fraction, it's the same thing as having it on the top. Okay, so if you have a negative on the outside, this is just like a little a guideline to follow here. I know we're not doing 2/3 right now, but it's similar. If you've got just a normal fraction with just a single number on the top and bottom, not like multiple terms on the top and bottom or any of those bigger fractions like we saw in chapter 8. No. Just a single number on the top and bottom, okay, or a single term even, but not multiple terms. Single term on the top and bottom. Then if you've got a negative on the outside only, or a negative on the top only, or a negative on the bottom only, those are all equal to each other because they're all negative. Okay? In the same way, if you've got two negatives, one on top, one on the bottom, not on the outside, but one on top, one on the bottom, that's the same thing as just having a positive fraction with no negatives at all, because they're both positive. Negative divided by negative is the same thing as positive divided by positive. So that's what I was pointing out here in this current problem. If you have a negative on the top of the fraction only, that's the only negative, it's the same thing as having the negative on the outside of the fraction. It's negative either way, and since the 3 and the 4 are the same, the overall answer is still the same because they're both negative. Since the 3 and the 4 are the same, the only question is it the same sign? And it is. It's the same sign, okay? They're both negative. All right, so that's the reason why these are both the same. So once again, we got the same correct answer doing two different methods right there. Okay, what about here? Well, as we learned just a few minutes ago, whenever you have a vertical line, the slope is always, 100% of the time, it is always undefined. Automatically, you don't even need to plug in these points. Okay, you don't have to do that rising and running thing. You could, if you want to, doing it the same way I did up here, but it's just a lot easier, and I'm okay with you doing it too. If you see that a line's vertical, it is automatically undefined, no doubt about it. There's no exceptions to that. It will always be undefined when it's vertical. Okay, but if you did it the other way, where you plugged in the x's and the y's. What are the x's and y's here? What's the first point and the second point? They are, and like I said, with horizontal and vertical, it doesn't matter which one you call the first point and which one's the second point. So I'll just say that the first point is the one on top, 1, 3, and then the one underneath it there is 1, -1. Now, if I were to try to do the slope formula, the one with the x's and y's in it, okay, I would get what? I would get -1 minus 3. In other words, I do the second x minus the first x. I'm sorry, I said that. I meant the second y minus the first y, because you always do the y's on top. Second y minus the first y, -1 minus 3. Okay, let me write that down. And then underneath that, it says to do the second x minus the first x. All right. And so we need to do what there? We need to do 1 minus 1, don't we? 1 minus 1. Right here, we got the 1 minus 1 right here. And so then we figure out what the fraction is equal to by figuring out what the top and bottom are, order of operations. And we get -4 over 0. But what is it when the denominator is 0? It is undefined, right? And so it's the same answer again. Okay, undefined, no matter which of the two methods you use, whether you use the graph, okay, like we did up here, or if we use the formula with the y2 minus y1, x2 minus x1 fraction. Either way, it's the same answer. Let's do one more here. This last one here is what kind of line? It is a horizontal line, because you can see it goes straight across. All right. If it's parallel to the x-axis, which is horizontal, it's definitely horizontal. That's a good guideline to follow. Just like whenever it's parallel to the y-axis, then that means that it is vertical. And so without even doing any calculations, we know that a horizontal line is always a 0 slope 100% of the time. So you don't need to do the work on that one if you don't want to. Just say the slope is 0. Okay. But if you want to do the other formula here, you're going to see that we get the same answer. Let me show you that. So the first point is -2, -3, and that second point over there is 3, -3. So using the slope formula, the big fraction, we get -3 minus -3. Now remember, -3 minus -3, when you have minus a negative, that becomes a plus, doesn't it? The first number stays the same, but when you have a number, any number at all, minus a negative, the minus negative becomes plus the second number there, all right? Plus the second number there. And so, how about the other part here? 3 minus -2. There we go again, all right? We're doing a number minus a negative. The second number is negative, so that creates a double negative. Minus a negative becomes plus. And then we calculate this thing. What do we get? 0 over 5, don't we? 0 over 5. And as we already talked about earlier, 0 divided by non-zero is 0 all the time. And so that agrees with what we calculated earlier. It's supposed to be a 0 slope. All horizontal lines are a 0 slope. Okay. And so those are the 4 different types of slopes. Okay. You could figure out the slope by graphing the 2 points if they're not graphed already, and then do the rise and run, or if it's negative, the drop and run. Or if it's vertical, you just realize that there is no run, and so you say that it's undefined because the denominator is 0, because the run is in the denominator. Or if it's horizontal, you then realize that there's no rise or drop, which is the numerator, and so then that tells you that it's going to be 0 over, and then you figure out how far it runs. But no matter how far it's going to run here, it's going to, since the top is 0, we know that whenever the top is 0, as long as the bottom isn't, you're going to get a answer of 0 for the slope. Okay, so 2 different ways of doing it, whether by the graph or by this formula down here. So I'll leave it up to you here. I'll let you guys try problems 1 through 4. You could either graph it and do what I just talked about, or you can use the formula. Probably be easier just to use the formula since I didn't graph it for you already. Okay, but either way you can do it. So try those 4 problems, hit the play button, we'll see how it comes out. Okay, what I'm going to do here, starting at number 1, is I'm going to go ahead and use the fraction method. If you did it with the graph method and you're not getting the same answer, please don't hesitate to let me know. Okay, I'll be glad to help you figure out what went wrong. Okay, but let's go ahead and look at the fraction method right here, and hopefully it'll come out the same for you. The second y minus the first y, that always goes on top. Second x minus the first x. All right, I got that set up. I calculated it. Okay, again, figure out what the top and bottom are equal to first, then put it in lowest terms if it's not already. Don't try to cancel or put it in lowest terms in any kind of way until after you've figured out the top and the bottom. Okay. So we get -8 over -3. You could leave the answer like that, but since, as we talked about a few minutes ago, since negative divided by negative is the same thing as just having no negatives at all, then you can just write it as 8/3. It's a little bit easier that way to write it that way with no negatives there. But yes, if you have negative on the top and bottom, not on the outside, but just the negatives on the top and the bottom, just having the negatives cancel out is fine, and that's perfectly legitimate, okay, to do that. So 8/3 is what we get. Number 2, let's do it again. We get what here? Second y minus first y. And second x minus the first x. Why is that a plus down there, even though the formula says minus in it? It's because it's that double negative thing. 0 minus a negative. The -3 goes behind the minus. When a negative is behind one of these minuses here, it becomes a double negative, like we said. And so 0 plus 3. So -5 over 3, you can leave the answer like that, but as we mentioned, if you prefer, you can move the negative to the front, because we know that when you have a negative on the top only and not on the bottom or on the outside, the negative could be moved to the outside and it's still the same answer. So you're welcome to move the negative as long as it's still going to be equal, all right, in its new position. And as we talked about again a few minutes ago, negative on top is the same thing as negative on the outside, as long as that's the only negative you have. All right. Number 3. 3 minus 3, 2 minus 5, you get 0 over -3. And we know that when the 0 is on top, it is 0, right? Finally, number 4. -1 minus 7. Second y minus first y, 2 minus 2, you end up with -8 over 0. And when the 0 is on the bottom, you guys, it's always undefined, isn't it? When the 0 is on the bottom, it's always undefined. So if I were to graph this thing, it would be a vertical line, wouldn't it? Because undefined slope is always vertical. It's always a vertical line. It always comes from a vertical line. The 0 slope is always horizontal. So if I were to graph these 2 points and draw a line through those 2 points, after I graph them, it would be a horizontal line, no doubt about it, no question. Okay, it would definitely be a horizontal. So just want you to see all the connections there between slopes and lines. Turning to the back side of the worksheet though now, okay, we're going to see how we can use slopes to actually graph the line, okay, when the line hasn't been graphed yet, okay. If the line hasn't been graphed yet, how can you use a slope to graph it? All right, we've seen graphs already in place on the first page of the worksheet that we just looked at, but what if we don't have the graph yet? We're all ready to graph here, but how do we do it based on this information? Well, on all 8 of these problems on the second page right here, all 8 of them going down here, in each case, they give you 1 point, and then they give you the slope. How is that different than the lines that we graphed in 4.1 and 4.2? In 4.1 and 4.2, we had to come up with 2 points, right? And then we connected them. This time we're coming up with just 1 point, and they're actually giving it to us, but the fact is that you can graph this with just 1 point instead of 2 points. And the reason why you're able to is because they also give you the slope. So in other words, you guys, if you know 2 points on a line, you can plot those 2 points, graph them, and then draw a line through it, and you've got your line. Okay, just like we did in 4.1 and 4.2. But you can also graph a line if you are given 1 point only, as long as they also gave you the slope. Let's see how that works. It all depends on what kind of slope you have. Okay, if the slope is positive, what does that mean? That means that we're going to what? Rise and run, isn't it? Rise and run. How far? Well, since it's 1/3, we're going to rise 1, and we're going to run 3 to the right. Correct? Make sure. The reason why I keep on saying to the right is because some students might misunderstand me when I say run. They might think that it's okay to run to the left. No. If you do it this way, you need to run to the right. I'm not saying that there isn't other ways to do the slope thing where you could go to the left, but that's a different method, and I don't want to throw too many methods at you, okay? I want to keep things as simple as possible since you're learning this for the first time. And so if it's a positive slope, you're rising and going to the right, rising and running to the right. If it's a negative slope like this one, that means you're going to drop and run to the right. All right. So here's what you do. If they give you 1 point and then they give you the slope, you always start out with that 1 point and you graph it. There it is right there, 1, 2 right there. And then you go from that point. You don't go somewhere else. You always go from that point. You build off of that, and you rise and run to the right, since the slope tells us to do that. So let me set it up here. But if we rise 1, it's going to take us to there. Now, don't put a point right there. We're not done yet until we do the run part also. So we rise 1, and then we go 1, 2, 3 to the right. Now you put that second point there. Okay, that's the other thing that slope is all about, is that if you know 1 point on a line, you can get to a second point on that same line by doing the rising and running or the dropping and running, depending on whether or not it's positive or negative slope. Okay, but you can do that rise and run or drop and run thing by going from the 1 point they gave you and then finding a second point. And the reason why that's important to find that second point is because, as we now know from 4.1 and 4.2, if we know 2 points on a line, what can we do? We can draw the line through those 2 points, right? As long as we know that both of those points are on the line, which they are. I know that they are because they told us that the first point was on there, 1, 2. The problem tells us that the line passes through that, so I know that point's on there. And then anytime you do the rise and run or drop and run, that will automatically bring you to another point on the line. And so I know that both of these points that I colored in right here, those are both definitely on the line, no question about it. Okay. Let's try it again. Again, you start out with the point, 4, 3. Okay. There it is right there. Now, this isn't a fraction, right? But remember, anytime you have something that's not a fraction, you can make it into one by putting a 1 underneath it, right? So if they give you a slope that's not a fraction, that's what you need to do, okay? Now that I know that it's negative, and I know it's negative because, just like I said, let me go back and just kind of look at it here one more time. If you've got a negative on top and no negative on the bottom, no negative on the outside either, that's all an example of a negative slope right there. All right. So this is a negative slope. That means what? That means that we're going to what? We're going to drop and run to the right. So we're going to drop 5, and then we're going to run 1 to the right. Okay? Like that. So let's go ahead and do the drop and run. And so let's count it out. 1, 2, 3, 4, 5. I drop 5, and then I need to run 1 to the right. It puts me right there. And now that I've done both the dropping and the running, I then color in my second point. And now that I have 2 points, what do, you guys? I draw my line, right? Because once you have your 2 points, that's all you need in order to draw a straight line through that. And then that straight line is the actual line that they're asking you to do here in this problem. Okay. The next 2 problems here, you can see is the slope is 0 and the slope is undefined. Good news. That's good news, because anytime you have a 0 slope, what is it automatically? You don't do the rising and dropping when you have a 0 slope or an undefined slope. What you do instead is you just simply say, oh, 0 is horizontal. And over here you say what? You say, oh, undefined. That means that it's automatically vertical. When you already know that you have a horizontal or vertical line, you guys, you don't need 2 points. Any other type of line, any diagonal line, you're going to need 2 points normally. Okay, but a horizontal vertical line, you don't need 2 points. You only need 1 point, which they give you already here. Okay, and the reason why is because you already know what direction the line's going in if you know that it's horizontal or vertical. And so you don't need that second point to point you in the correct direction. All right, when we did the second points on these 2 graphs, that second point was what told us what direction our pencil was supposed to go when we drew it. Horizontal vertical tells us already what the direction is, so we don't need no second point. Okay, just draw the one or color in the first point, and then follow the direction here, whether it's horizontal or vertical. The first problem here, it's horizontal, and so I'm going to draw a horizontal line through that. And that's it, okay? So again, with a horizontal and vertical line, you just need 1 point as a starting off point. Okay, obviously you're going to need 1 point. You can't go with no points at all, because otherwise you wouldn't know where the horizontal line is. It could be up here, it could be way down here. But the fact that they gave you this 1 point right here, now you know that it's got to be this horizontal line right here. Okay, so but 1 point is all you need though. Same thing with vertical. You graph your point. 2, 0 is right here, so I'm going to color in that point that they gave me. And then since it's vertical, what do? We just draw a vertical line through that. Again, only 1 point needed with vertical and horizontal. Okay, we already know what direction the graph is going. And there we go. Okay, so that is how to graph a line if they give you 1 point. No equation this time, but they give you 1 point and they give you the slope. You now know what to do. Now these last 4 problems in the second page here are exactly the same. They just did a little bit different numbers, but it's the same 4 types of problems. Please try that right now, and then we'll wrap things up after you hit the play button again. Okay, you can see that I kind of started things off here with each problem. I haven't finished it yet. Okay, let's finish it together here and we'll see if it comes out the same as yours, as your answers that you have. Again, whenever they give you a point and then they give you the slope and they ask you to graph it, always start out with the point on the graph and then use the slope to get to the next point. Unless it's horizontal or vertical, in which case you don't need a second point. We talked about that, and we'll talk about that again here in just a moment. But in the first two graphs, we'll find a second point here. Here, since the slope's positive and since it's just a regular whole number, I make it into a fraction by putting it over 1, 3 over 1. And that means that since it's positive, it's going to be rise and run. Let's do that. So I'm going to rise 3, 1, 2, 3, and then I'm going to run 1 to the right, and it's going to take me right to this point right here on the y-axis. Okay, and now that I've got my second point, I draw my line, right? There we go. Don't forget to put your arrows on your lines. And let's move on to the next one here. Always start out at the point. Because it's a negative slope, we're going to drop and run. So let's do that carefully here. I'm going to take that point and I'm going to drop 2, 1, 2. Okay, and then I'm going to run 5. 1, 2, 3, 4, 5. You can see I went past the edge of the graph there. It is okay for you to extend out the axis there so it'll fit. All right. A lot easier to do that instead of trying to make the marks really small. Although if you did that, that's fine too, as long as it came out, as long as you're able to fit it in there. Okay, and I'm able to see what you're doing there. That's fine. Okay, the marks could be different sizes. Okay, it's just that the marks have to be the same distance apart. We've talked about that before, but that would work too. Let me go ahead and graph this now since I've got my 2 points now. Again, I dropped 2 and I ran 5, correct? And so then I drew my line. Put your arrows on each end right there. Okay, and that's number 2. That's for, it's not a surprise that that graph goes down as we move from left to right. All negative slopes are like that. Okay, it's not a surprise that this one goes up as you move from the left of the graph to the right of the graph. It's moving up. It's because the slope, when it's positive, will always have a graph like that. Okay, it is also 100% true all the time that a zero slope is horizontal and an undefined slope is vertical. And so, like I said a few minutes ago, when you already know the line's horizontal, all you need is 1 point. You graph it. And then you just draw a horizontal line through it because you already know the horizontal part tells you what direction you're going in. No second point is needed when you already know the direction. Okay. Since this is vertical, once again, you start out with the point that they gave you. You draw a vertical line through that, just like we did on problem D up above. And that's it. Okay. Okay, so sometimes positive, sometimes negative, sometimes a zero slope, which is horizontal, sometimes an undefined slope, which is vertical. Okay, we'll be learning more about slopes and how they relate to equations in the next section. But for now, if you have any questions about the types of slope problems that we did in this section, let me know, of course. Okay. And you take care and have a good day, and we'll see you back for section 4.4.